Hi, we are students from Harmony School of Innovation in Garland. Our PBL project is Atwood's machine. Atwood's machine is a common laboratory experiment that verifies the mechanical laws of motion with constant acceleration. It was invented by George Atwood, an English mathematician, in 1784. The machine consists of two masses, m1 and m2, and a pulley. If m1 is smaller than m2 in mass, m2 will accelerate downward and m1 will accelerate upward. If the string is tight and does not experience stretching, both m1 and m2 will encounter the same force and same acceleration and can be considered a single system. The acceleration of the machine is considered based on m1 and m2, from both the difference and the sum of two masses. The main purpose of this project is to discover how mass plays a factor in acceleration in Atwood's machine. Our materials were data collection system, smart gate photo gate, super pulley with mounting rod, mast and hanger set, table clamp or large base, support rod 60 centimeters or taller, right angle clamp, thread, and scissors. In part 1 of the experiment, we began by having 0.145 kilograms of mass in mass 1 and 0.200 kilograms in mass 2. We then transferred 0.5 kilograms to mass 1 from mass 2, and so on throughout the trials. To determine our acceleration, we used a capstone program that displays linear speed and its time as its x and y intercepts. We took 2 points from the table generated to the left and used the slope formula to determine our acceleration. This is our table based on the exchange of masses, and this is our graph based on the accelerations. As you can see, the acceleration kept increasing throughout each trial. In part 2 of the experiment, our masses began to decrease on both sides. Because of this change, our acceleration began to lower at a constant rate. This is our table based on the change of masses. As you can see, the acceleration kept decreasing throughout each trial. This is our graph based on the accelerations in part 2. According to our analysis, masses affect acceleration as a whole. In Atwood's machine, mass and acceleration go hand in hand and go into the equation. M total times acceleration equals m2 times gravity minus m1 times gravity. Has masses on both sides which influence how the result will output. For our ELA component, we chose a narrative essay as the format to illustrate our project. The PBL project we were assigned was Atwood's machine. The purpose of this project was to find out how mass plays a factor in acceleration in Atwood's machine, as well as how it used to prove Newton's second law of motion. Thus, we started to research and learn more about our project, while learning interesting facts about how the past of the machine has made up current machines that make up part of our daily lives, and how certain equations are used to calculate different processes on Atwood's machine. Overall, the project conducted went well. In the end, we understood how mass plays a factor in acceleration in Atwood's machine. For our social studies component, we chose a historical connection as the format to illustrate our project. Through history, Atwood's machine has improved the lives of many. People have created welds, elevators, and garage doors from this model. It is applied to everyday tasks and objects and is unrecognized when it comes into use. Atwood's machine was invented by mathematician George Atwood in the year 1784. Atwood is known for a textbook on Newtonian mechanics describing impact and the harmony of motion. This machine overall demonstrates the basic principles of acceleration and dynamics, which goes all the way to the 17th and 18th century. Thanks for watching Harmony School of Innovation.